Saludos, mis gatitos, and welcome to this presentation in geometry, and in particular we'll be talking about function notation for translations. It's probably a good idea to have an idea of what a translation is, and the dictionary says that a translation, a geometric translation, moves every point of a figure by the same distance in any given direction. It's important to note that during a translation, the size of the object is constant. It does not change at all. And since the size does not change, this is a rigid body transformation. Later in the semester, we'll be doing translations or other transformations actually that are not rigid body transformations, and the size of the object that we're operating on will change. And finally, the orientation of the object does not change during a simple translation. Now, we're talking about function notation for translations, and it looks like this. The T, nice motorcycle sounds. The T says that we're going to translate some object, in this case triangle ABC. And now we have to tell it how we're going to operate on that object. And that comes right here. The 3 says that we're going to move every point on the object 3 units along the x-axis to the right. This is like x, comma, y. We're moving 3 units to the right, and we're going to be moving 6 units down in the coordinate plane. With all of that said, that results in this image of the original object, and we'll name that A prime, B prime, C prime. So let's see how that works. In this example, we have a point A right here, and we want to move it to that point right there. If we look carefully at this and we draw in a triangle like we do for slope, this is a little bit different. We can see that to go from A to A prime, we have to move 4 units to the right. And if I count 1, 2, 3, 4, 5, and we have to move 6 units up. That's in the positive direction. Both of these numbers are in the positive direction whenever we move A to A prime. To specify that in function notation, we would write it like this, that T says to translate it or move it, and then the superscripts here, 4 and 6, indicates that we're going to move it 4 to the right and 6 up. The object is A that we're going to operate on, and at the end of that we're going to call it A prime. So here we took the points, the coordinates for point A, which was 3, 2, and we added 4 to it to get 7, and we added 6 to the 2 to get 8, and that's our translation. Those are the new coordinates for the translated object. Those are the coordinates for the image after the translation. We'll do another simple translation of a point. In this case, we're going to move point A to A prime. If we go ahead and draw in our triangle, that wasn't exactly right. Let's try again. So to get from point A, we have to move, this is 6 units plus 4 units. We have to move 10 units to the right, and to go from A to A prime, we have to move 1, 2, 3, 4, 5, 6 units down. That would be -6. So when I write my function notation, it's going to be t, which means translate. We're going to move 10 to the right and 6 down. We're operating on object A, and we're going to call the image A prime. The original coordinates of point A was -6, 9. And to get the coordinates of A prime, we're going to add 10 to that -6. So that's going to be -6, add 10. That's going to be my x coordinate. That's going to be 4. And then to get the new y coordinate, it's going to be 9 subtract 6, and that would be 3. Now, it doesn't have to be a single point that we translate. We can translate a geometric figure like this triangle ABC, and the function is this. We want to take triangle ABC and translate it 6 to the right and then 9 units down. To start, why don't you go ahead and determine what the coordinates are for points A, B, and C. So here are the coordinates for points A, B, and C. You may want to check me on that. So this is -6, 5. B is going to be -5, 9. And point C, -3, 5. You're going to translate those 3 points 6 to the right and 9 down. So what you're going to do here is for the x's, you're going to add 6. For the y's, you're going to subtract 9. Once you take a minute and determine what the coordinates are for the image A prime, B prime, and C prime. Here's what I got. Notice that for -6, 5 in the original object. We added 6. And for the y's, we subtracted 9. So 6 add -6 is going to be 0, 5. Subtract 9 gives me a -4. And that's what I got here. You would do exactly the same calculations for points B and C, and hopefully I'm right with these new coordinates. Now here's one for you to do. I want you to come up with the function notation that's going to be t and some numbers here, and you're going to be operating on A, B, and C to go to the image A prime, B prime, C prime. These numbers here, A and B, will be the same for any point on the original image, right? Once you get it for either A, B, or C to A prime, B prime, or C prime, you've got it for all of them, because nothing's happening to the image other than we're translating it. All we're doing is moving it, not rotating it, not flipping it, not changing its size, nothing. All you have to do is get A and B in this case for any one of those 3 points, and you've got it for the entire image. Here's the result that I got. Let's see, I'm going to take A to A prime. So I'm going to start right here. I'm moving to the right. So I've already moved 10. 1, 2, 3, 4, 5. So that's going to be 15 to the right. And then I'm at -8. To go from -8 to 0 is 8. And then up one more, and that's 9. So that's where I got the 15 and the 9. And I can do exactly the same thing to point B to go to B prime and C to go to C prime, and I'll get exactly the same result. That about wraps it up for this presentation. And at the end of the day, there's only one thing left to say, and that is, that's all, folks. Thanks for watching. Thanks for learning. Stay safe. Con cuidado.